I struggled in my college days to do a Unix program. I still couldn't figure out what exactly exists in hash. Yesterday I wrote a hash before I input it in a C program. Luckily VB came for rescue, simplify semantics, simplify things, simplify editor. Okay, fine. Can do something meaningfully without trying to bog down with the technical difficulties which we went through. So fascinated by the editor, the journey started with 5 and 6 when .NET came. Once again, it's time now for us to revise the fundamentals. Once again, I have to visit the C++ books, try to revise what is my object classes, because if not, still continue the area with this object-based approach with Visual Basic class. Luckily, I still survive in this industry with my knowledge of Visual Basic and little bit on C#. Of course, I'm also on and off, but still I'm maintaining my rhythm in this industry. So all said and done, I have my master's in physics and management from Chennai. And the theme of the day is where I began my journey. Actually, I am wondering on the day one why we have to repeatedly store the key information in 2 tables to create a join. Because it's something that your design gives to you upfront. But the problem is, when I read the Course law, he said clearly the database has to be represented in 2 dimensions. That's fine. The table-like format is very much needed for pinning down the information accurately about a column and then the table definition. Fine. But the problem is, when you do the things from our side, we create the table, create columns, the constraints, then we try to relate. So beyond first normal, that is of defining the primary key, the second normal comes to the picture where you have to repeatedly store the same key information to relate 2 tables. Suppose I have employee master, destination master. Employee is a primary key and employee master is fine. Destination ID is a primary key and destination master is fine. So suppose if I want to relate these 2 tables, I have to have a very basic join operation saying that select star from employee master, comma destination master, where employee master dot destination ID equal to destination master dot destination ID. Okay, this is something to begin with, but how many conscious joining operations I have to perform this way to do a thing which we know exists in the requirement? So my train is something like this. I want to create tables as an abstraction over the underlying data structure. Meaning, I can have a table of employee master with only employee and name. I can have something more if the join permits, or something like a Boyce code normal where all the relations can be envisaged as employee master because everything is centered around the same employee information. So that's, if you want to achieve that, the challenge is enormous. Because most of the RDBMS relies on the fact you begin with the table. Then you have the constraints that are different clearly. The table, a column, and constraint, then the join, then out of the join you derive the interface, reports, and other scheduled jobs running around the database state. Okay, so what would be a possible solution? Little algebra and little proximity theorem I employed here. Suppose I, instead of putting the primary key on a flat table, I assemble it with a floral pattern, center down the primary key in the innermost sector, then group the p key. This p key or star indicates all the candidate keys sitting near the primary key. That is the name, salary, or whatever. Then I can extend the primary key with fk1 and say fk1 or star here, and then fk2 here. Little algebraic formulation, little proximity theorem, I found out that any join operation which you perform is basically centered around the key paths. How the keys arrange themselves finally dictates the behavior of your queries, your joins, and finally the interface definition. So, if you want to have, if you do something like this, the namespaces can be spelled out this way. You can say pk1.star and then say pk1.fk1.star and then pk1.fk1.fk2.star. And then if I say pk1.star is nothing but pk1.att1, att2, and att3 till attn. Fine? Then this document then speaks about many practical difficulties, and let me minimize this. Okay, so what would be a best example to demonstrate the capabilities of this model to be where the scenario says there is a very huge volume explosion and data explosion. A very ideal candidate could be a railway reservation system. In a railway reservation system, if you want to archive, especially in like Indian Railways, if you want to archive the passengers who have traveled across the length and breadth of the country for a week, spanning all the trains, all the stations, and all the schedules, you ultimately end up with archiving 1 crore records for 1 week. So that could be a very ideal candidate for demonstrating few of the capabilities which I have envisaged in this power model. Okay, I don't have expertise in kernel programming of SQL Server or Oracle or how internally they do the data structure manipulation. But however, I have studied a bit about the B plus T, beam, B trees and other ways of. And the first comment I got from an expert is, he said memory is single dimensional. It cannot be exploited the way I have envisaged. That's what he told. Okay, fine. If memory is linear, is there any parallel way to do the same task? Okay, suppose I take a railway reservation system. The fundamental master is train master and then a station master. So what would be the relation? A train stopping in different stations, or in a single station many train arrives and leaves. Okay, what is? A train adhering to different schedules, and in a single schedule many trains exist. Many compartments are attached to a train, and in a single compartment gets arrived from different trains. In a single train many passenger travels, or a single passenger travels on a specific date on a specific train on a specific seat on a specific compartment. Okay, so once again, I found a justice when I visualized there is a much more meaning when we say the keys gets related, not the table as a whole. Instead of spelling out the relation between the tables with repeated keys, if I segregate the key paths, much more meaningful derivations I got. So what happens is, it's very simple. I did this POC with a very simple XML approach. So when I store this, the train ID, the station ID, the number of kilometers, which indicates the first or second or whatever, the time of arrival, the date of journey. Now you see all the meaningful relational joins reside in the key paths, not in the base table. Base table is something which gives you the foundation information to build out things. But the joins are much more meaningful when I speak from the key path scenario. So, if I create parallel XML files, the moment I create train station relation, if I create another XML for station train relation, where the station ID becomes the enumerated column to begin with, then the train. So in a join operation which we normally perform, we call it as group by, having process, order by, etc. Fine. Now, if I have this kind of XML based namespaces, so train ID.star is your base namespace, station ID.star is the station master, schedule ID.star is your schedule master, The compartment ID dot star is the compartment master, seat ID dot star is the seat master, passenger master, ticket master, whatever. Now the second node namespace, I enumerate train ID dot station ID, train ID dot schedule ID, train ID dot compartment ID, train ID dot passenger ID. Now the challenge is I am trying to move away from this join operation group by AVI by introducing this kind of a namespace-based construction of parallel namespaces where it enumerate all the joins. The first example I showed you is when I create the train station relation, I parallelly create the station train relation and serialize it as an XML file in a SQL server. Now you see what I attempted. So I finally retort to a kind of history, relation history XML where all the possible key pairs are enumerated and the relevant XML files are stored. So ultimately I have a database with free floating tables and nevertheless I never moved away from the concept of primary keys, unique identifiers are recorded in independent tables, fine. The joins are attempted to do something like kind of a key pairs segregated and meaningfully collated and serialized as XML files in the same SQL server. And in the middle where I try to use this ordinary data set with read and write XML, just read the XML file, use the filter, find, sort criteria which data set gives you, do all the interface. I have a complete application developed, but I have no time to show everything. But anyhow, the screenshot says all the meaningful things. In fact, I try to do something for a multi-user scenarios, whether this kind of design helps to solve any implemented problems there. So in a way, the interface definitions got florally manifested. So integrity is also maintained from the primary tables. The XMLS has the tendency to get corrupted easily. However, XML serialization in SQL Server is handy to solve that issue. So now the idea is how to write a query, better query. If I have something like this in my hand. So instead of saying select star from train master, I say select train ID dot star. So the grouping. If you go after the second normal, for a particular train, for a particular compartment, how many seats? The single compartment, how many seats exists and how all the passengers travel. So only two challenges are left to solve in this problem. The more related the namespaces are, the more will the duplication of records in the result set of query. Minimize the same by enforcing filter criteria in the columns that are fixed out of the join operation. An exhaustive query similar to Boy's code normal form will result in voluminous results which has to be taken in. Okay, what is a Boy's code normal form here? Very simple. Give me all the trains traveled through all the length and breadth of the country, across all the stations. I want all the scheduled train, all the cancelled train, people who have traveled, people who have cancelled the tickets, people who have booked the tickets, how much payment is made, how much returns are made. Fine, I have some answer from this approach. Okay, so coming back to the basic task which I started. Move away from a kind of a rigid linear relation. With the employee master, with the sitting with the designation ID and structure ID, try to do something like this. Of course, what we are attempting is something meaningful, a conscious join operation. But if I know clearly, this is something that has to result in the structure of the database. Why I have to necessarily perform a conscious join operation to relate a table, two tables to deliver meaningful information. So this POC also demonstrates me my idea, yes, joins revolve around the key paths, not on the base tables. So if I have a better way to relate the keys, one way could be the for pattern. The other way could be even an XML can very handy in segregating and decoupling and coupling again. So there should be a better solution to attack this problem. So ultimately, the culmination could be to achieve a physical and logical data independence. The definition of the data doesn't get tied down to the definition of the table. You get a much more decoupled layer, much more cohesive performance. So you don't need to have expensive stored procedures, you don't need to have expensive triggers to be written. A kind of a simplified mechanism to do the overall RDBMS operation. So basically this achieves a relational voluminous explosion to be simplified to the greater extent. Still the roots are there, we hit the base table with the primary key, but the organization of the keys to arrive at the relation is little different. That's basically I'm trying to drive on. Okay, so very much. So the other advantages in this kind of querying is voice recognition queries. So what is voice recognition basically? We have a predicate, we have a subject, we have a clause. That's how human beings communicate. If the things are decoupled to a great extent, I can say, give me a set of tickets, or should not be expressed. Well, answer maybe 30 minutes before the start of the game, around 12:30. Now I have, the person who is operating the computer does not sit with the interface. He can have a guiding sheet where you can say, just get a kind of training, whereby you can have nouns properly placed. These nouns maybe should have the express, and cancellation of tickets may be a verb or moving verb. Form of clauses in such a way we directly try to relate what we try to relate to Singer using our communication. And then, since it is so decoupled, the joins are much more meaningful. You can spell out something like English SQL. So instead of doing a keyboard operation or a job or a query, the voice recognized query could fetch a much better result in much faster manner. That's what I feel if simplified queries semantics can take place. Since mathematically the query strategy is simplified, any attribute tuple based relation queries can be spelled out in English queries, since what you achieve is loosely coupled and cohesive querying strategy. So instead of typing a lengthy query on with querying semantics, the simplified version of querying can be enhanced with voice based querying. Whereby certain keywords can be coupled together semantically so that the spelled out sentences can be converted into query and the fetch can be triggered to form from the database layer. Okay. So the next thing is okay. So since I use XML, I referred one book by Kurt Kettle. He's a Microsoft most valued professional. He introduced the book on XML even before .NET came. In that he has struggled a lot to just assemble so many DTTs. That's how we used to do it earlier. Now things are simplified because of the .NET framework. And in the concluding part of his introduction, he said XML, if enhanced to a greater extent, can reveal the hidden aspects of consciousness. That's how we entered the interface. I also find even the linear representation and even paves way to the similar answers. So even XML is very handy to do a kind of join which human beings try to consciously do things. So this is one of the inferences which I took. And so the next task would be, can you do something on the data structure level so that this struggle with XML even can be fed into the kernel portion where the semantic queries and other things reside. So the SQL Server or Oracle does it now. We don't know what they're doing, because it's a little higher level understanding. So these are the things which I am trying to drive on in this talk. Okay, so it includes questions. Okay, fine. I welcome all sorts of questions, but however, this is an attempt from a programmer perspective. because the day when we sit before the program with the program, we wonder how why things are to be done this way. That when we always also does the same thing, and even a person who wants to do something meaningful also tries to do the same thing. The thing is, whether I don't know. My point is something even I don't know. So the questions can be focused on what actually I have accomplished. And if you ask something where things doesn't reside in this coverage, I don't have a proper answer. Okay. Yes.
You talked about the voice code.
Okay.
How it is related to NLP, the natural language
Uh, you were speaking about natural language programming or neural linguistic programming.
natural language program, because it's very different about the face, noun, the way that we speak about it.
Many researchers are happening even in the Indian Institute of Technologies for voice recognition, but their focus on is on something, the area is something different. More of the mathematical manipulation is what they are attempting towards. This is something on the application side. So I don't have an answer to how to do it mathematically, but this is once again centering towards kind of better semantic relation. When things are much more decoupled, much more pervasive, much more inclusive. And I also pulled out some interesting discussion on proximity theorems. Proximity theorems means when you say something, two things are near each other, how far, how much. When you want to do something mathematically on that, extensive discussion on it. So I don't want to enter into that, but this is what I am trying to do. Okay.
What are we primarily achieving by doing this pattern of is it ease in better performance? Is it reducing joints? Sorry, I came in a bit later.
Oh, okay, fine. See, the attempt is very simple. We want to make tables which has abstraction over the underlying data structure. Every time we don't want to perform a conscious join operation to the data. Because I know by definition of the data definition, I know this are related this way. So I'm trying to enforce a model which directly attacks that problem and create a data structure which is much more nearer. So the tables can be spelled out as an abstraction over the underlying data structure. You do not begin from tables. You can begin something little fundamental and build the tables over. So that's what I am attempting to do. So I gave the answer. If I want to have employee master with ID and name, fine. If I want to have with ID name, salaries, age, fine. Or if I want to do something like a all pervasive join with all the meaningful information which an employee is sitting in an organization, that's also fine for me as an employee master. It doesn't disturb the employee master table, it is a rigid definition. As of now.
So it like helps in getting data in different formats. It's a better way of
organizing. Yeah, exactly. Organizing the data so that the queries can be much more simplified. The performance has got its own improvement areas and performance layers. Now.
You showed a floral diagram in which you store the PK1 in the atmosphere. That is according to theory wise or according to?
No, that is an algebraic question. That PK1 is a notation for a family key. PK1 or star indicates whatever, yeah, you want to put it on the PK1. Now basically the problem is, in the existing normalization, we have employee ID, fine, employee name, salary, age. Now when we introduce the designation ID in the same table, all the set of columns which are sitting dependent on employee ID gets extracted because that row and designation ID is a kind of a job which is primarily centered on employee ID. Now, if I extend it beyond a second normal, that is a third normal, if I have a location ID and then qualify the designation with the location, now the problem multiplies. That's precisely the area I am talking about. So now you see, if I want to say something, when a person is getting transferred from or getting promoted from one designation to another designation, the disturbance is vast because you have enforced a destination in the column exactly which is spanning across all the columns, all the rows. Then I say select star for employee comma destination, employee headmaster comma destination master where employee destination equal destination master destination ID. Something which is create more problems when you go to third normal, and beyond that it's become a lot of mathematics comes into play to do a simple job. So I put an algebraic version. Say pk1, then pk1 dot star, then forwardly segregate the fk1s. So you end up in creating namespaces. pk1 dot fk1 dot star, pk1 dot fk2, fk1 dot fk2, fk1 still fkn. So the keys revolve around each other together. Once you relate, if the base table with the primary, with the natural indexing falling on the primary. Any more questions? And I take this opportunity to people to see many meaningful things can be done out of this approach because I have tried to do something fundamentally it's a very big necessity for us. Because after this, beyond third normal people sit with external stored procedures, and if a person has written SP leaves organization, I'm still studying with SPs written by a person who doesn't know basic data types. So the problem is enormous. Maintenance headaches keeps it. So is there a way where people can simplify this data-centric illnesses? That's what I term this overall scenario existing currently. So I want to welcome everybody to contribute this to this idea, and I'm not take the blog and all. Yeah, I'm trying to do something more meaningful after this. Okay.
So we'll be passing stickies. So please give your feedback and write your feedback and give it to us. Share the screen. After connecting, we can check. So it will be like clicking your screen. You can start.